We now return to the Practical Guide to the Universe on the Learning Channel. Our sun radiates throughout the entire electromagnetic spectrum, and this radiation is all the same energy, whether it is gamma rays, visible light, or extremely long radio waves. The higher the wave frequency, the greater the amount of energy it contains. To give a sense of this energy, we might compare being bathed in long radio waves to being pelted with popcorn. Gamma rays, which are on the opposite side of the spectrum, carry the punch of a bullet. The point is that as the frequency increases, the energy also increases. Ultraviolet, X-rays, and gamma rays have so much energy they easily penetrate matter and can therefore damage the tissue of living things. The part of the electromagnetic spectrum we call light is only light because we can directly see it. Our eyes have evolved to respond to this very narrow band of electromagnetic energy. You may wonder why we only see in this area of the spectrum and not another. The answer is because this is the part of the spectrum where the sun releases almost all of its energy. We see in this segment of the spectrum because that is where there is the most to see. Our eyes would have to be the size of giant dish antennas to see the feeble radio wave energy our sun emits, and the same is true for X-rays, gamma rays, and all the rest of the spectrum except visible light. Earth's atmosphere further restricts the tiny amount of other solar radiation we receive on the surface so that only extremely small amounts of X-ray, gamma rays, and ultraviolet rays get through. The sun radiates mostly in the visible range because of the temperature of the photosphere, where almost all the sun's radiation comes from. You can see why with a simple lamp. In these glowing coils, you see only red because the temperature is about 1500 degrees. The wire is radiating, but only a small portion of the radiation is visible. Most of what is radiated from the coils we experience in a different way, as heat. The wire is giving off energy mainly in the infrared portion of the spectrum. Raise its temperature to 3700 degrees, and it produces the same quality of light as an incandescent light bulb. Heating it to 6000 degrees will produce that crisp white light we recognize as coming from the sun. Raise the temperature still further, say to 30,000 degrees, and the coil appears to dim somewhat because at that temperature it radiates most of its energy in the ultraviolet spectrum. I would not see it, but would get a terrible sunburn and possibly go blind. We do not see the rays which damage our eyes. The radiation coming from the sun is very normal for its size and type, but in one area it is happily different. Life on Earth is lucky to have a star that is below average in its output of X-rays. Many ordinary stars, and several that are cooler than our sun, throw out a larger percentage of their energy in the form of X-rays and gamma rays. If our sun did that, all life on Earth would be at risk. The sun is the most studied star in the galaxy, not only because it's the closest, but because it's so essential for life to continue. If the amount of energy the sun puts out were to vary, even by a small amount, Earth's climate could change catastrophically. Minor changes in the Earth's climate seem to be tied to cycles in the sun's activity, where spots on the sun apparently come and go in 11-year cycles, but these changes don't seem to be large enough to affect the Earth's climate permanently. Some scientists, looking at the geological record of the past weather patterns, see even longer cycles in the sun's activity. Longer and more devastating. These cycles last 25,000 or 50,000 years and could trigger ice ages. In order to survive over the long term, we need to learn about these changes so we can adapt if necessary. But changes in our sun are as inevitable as the changes that take place in all things as they age. And one day, our sun is destined to die, and our solar system with it.
Now, when the sun burns up all of its nuclear fuel, which it gradually is doing, and will take maybe another 5 or 10 billion years to do it, then something else will happen. And it will somehow readjust its structure so that it continue to stay hot. Now, one thing it might do is it might expand greatly, and the outside surface of it might actually approach the surface of the Earth, So although the sun would then be cooler, it would still be overall producing more energy than it does now. So it would get awfully hot right here. And we would want to have space travel by then so we could go live someplace else.
Spectacular as it sounds, the red giant stage is just the last gasp of a dying star. After the great expansion of its sphere, our sun will collapse and shrink in upon itself to form a white dwarf. This is a small star, incredibly dense, with no nuclear energy left. Our sun will die as a glowing cinder slowly cooling to become a cold rock called a black dwarf.
What would happen to life as we imagine it here on Earth? 5 billion years from now, will there be human Homo sapiens-like beings on Earth or throughout the solar system? And it's hard to predict. Would we be able to accommodate the massive change in environment that we're used to on the basis of the sun? And will we as human beings be able to progress, evolve, mutate to accommodate incredibly different environments in our solar system then? And I guess I'll take the bullish approach and say yes. I think by then, if we haven't killed ourselves off and we've in fact endeavored to explore the other planets and even move beyond this solar system, that we should be able to accommodate the destruction and the end, the slow dying out of our solar system.
As we have seen, the sun is truly the source of all life on our planet, and whether we like it or not, we are all part of the great spectacle that is the universe. Our destinies are intertwined with that of the cosmos, and in that sense, we are all children of the sun.
Did you know that we're all made of stardust? See how the fallout from exploding stars helped create our galaxy. Next on the Practical Guide to the Universe from TLC.